Okay, so this is prep test 70, game 2. This is an in and out game, so we will be doing circle slash. Um, so we have a corporate manager is selecting employees for a research team. The team will include at least 4 employees, all from the following 8. So we have M, O, P, S, T, W, Y, and Z. Now, because we have the rule that we have to have at least 4, I'm going to write off to the side 1, 2, 3, 4. That's going to tell me that I actually have to fill up all of these. Doesn't mean that I have to have a maximum of 4. I could have more than 4, but this tells me that if I can't fill up all my spaces, it's an invalid world because I have to have at least 4. So, yeah. Okay. And then just as a reminder for circle slash, we have our circle being in and our slash being out. So when a variable is in, we're going to circle it. When a variable is out, we're going to slash it. So first rule says if Myers is on the team, neither O nor P can be on the team. So right now, none of our variables are assigned. And because this is an if-then statement, it means that we only have 2 options, if it's happening or if it's not happening. So before we do anything, we're going to look at our if statement, which says if Myers is on the team. So we're looking at M. So we could have a world where Myers is on the team. We could also have a world where Myers is not on the team. So we're going to make that happen. Oh my goodness. I'm just so sloppy today. So we're going to make one where Myers is on the team, Myers is not on the team. When we know that the rule applies when Myers is on the team, and we know what happens when it is. So when Myers is on the team, we know that we can't have O and we can't have P, so we can automatically cross those out. Our rule does not say what happens when Myers is not on the team, so we're going to leave it as is. We're not going to worry about the contrapositive because we don't have a rule that tells us what happens when Myers is not on the team. So we're just going to leave it as is. It could be that both O and P are out, but it could also be that one of them is in, both of them are in. We're going to leave it as is. Now, when I have dashes to the side, when I'm hitting a minimum that I have to have in my group, I go and I write my letters as I circle them. So when I finish with a rule, I'm going to write my letter to the side. Really doesn't matter when you write your letter to the side. If you want to go through all of your rules and then write your letters to the side, that's fine. Personal preference, I just do it as I go. So I'm going to write M on the side because I have M circled. Next rule says if S is on the team, both P and T must also be on the team. So we're going to go all the way back up to our first world. We don't know where S is. So what we're going to do is we're going to create our copy because it can either be in or it can be out. So we're going to make one where S is in and where S is out. And we know what happens when S is in. P and T must also be in. But I already have P crossed out. So this world can't happen. This is invalid. This violates one of our rules. Cross that out. When S does not happen, we don't know what happens. So we just have to leave it as is. We cannot do anything else. There's no rule that says what happens when S does not happen. So we're going to move on to our rule 2, or not rule 2, world 2. We're going to make our copy because in world 2, we also do not know where S is. So we're going to make a world where S is in and where S is out. The rule says what happens when S is in. So that's happening in my second world. When S is in, we know that P and T must also be in. So we're going to circle P and T. I'm going to write them to the side. Cross that out before I get confused. And we're going to leave that as is. When S is out, we again do not know what happens. So we're just going to leave that fourth world, this world down here, we're going to leave it as is. Okay. Last rule says if W is on the team, both M and Y must also be on the team. So we don't know where W is in any of our worlds. So our first world, we're going to make our copy. So we're going to make one where W is in, where W is out. We know what happens when W is in. We have M and Y in. But because M is already canceled, this world does not exist then. It violates one of our rules. So we can cross that out. When W is not in, we don't know what happens, so we're just going to leave it as is for right now. Going into our next rule, don't know where W is in, so we're going to create a copy. So we're going to circle W in one, we're going to slash W in the other. When W is in, we know that according to the rule, M and Y must also be in. So we're going to circle Y. We're going to place our variables to the side, which is M, W, Y. When W is out, we don't know what happens because there's no rule that says what happens. So we're going to move on. Moving down to my other world, we don't know where W is, so we're going to have to make a copy and make sure that we do know where W is. So we're going to make one where we do know where W is in and one where W is out. According to the rule, when W is in, M and Y must also be in. But in this world, we already have M slash, so we can just completely eliminate this world. And when W is out, we don't know what happens. Okay, so that was the last rule that we had. But we're not done there because there's a stipulation that we have to have at minimum 4. We have to make sure that we have at least 4 within our group. So going into this world, we have M, Y, and W. We're missing one more variable. Make it a little bit straighter. One more variable, and because we've crossed out 3 of them, we are between T and Z. I'm going to write it out to the side like this because we could have a scenario in which both of them are existing. We could have it be where T and Z are with M, Y, and W, but we just have to make sure at least one of them is in there. So I don't want to make it look like we can only have one of them in there. It could be true that both of them are in there. So I'm going to write it like that. And because this was our last rule and we don't really have anything else to go over in that world, I'm going to check mark it. Next, we have P, S, and T, and we are left with O, Y, and Z as our floaters. Again, I'm going to have at least one of them in there, but they could all 3 be in there. Could be true that only 2 of them are in there. We just have to have one more in there. So I'm going to write them out to the side as floaters. Valid world. Done with that. Next, I have M, and I have 3 spots left, and I actually have only 3 variables that are not crossed out. So these 3 variables actually have to go into my diagram. So they actually have to be chosen in order for this world to exist. So we're going to check mark that one. Next, we have none of our variables placed on the side, but we have our floaters, which is O, P, T, Y, and Z. We have to have at least 4. We could have all 5, but it can be any combination of them that are in this world. So I'm going to write it up to the side as a floater. And that's the game. There's really only like 4-ish worlds that we're working with here. So fairly easy. Okay, we're gonna go through our answer or our questions now. Question 8 says, which one of the following is a possible selection of employees for the team? So it's our typical list question, and in order to attack it, we're going to go through our answer choices and see which ones are violating them. First thing I'm going to actually check is, I know I have to have a minimum of 4, so I'm going to make sure that there's at least 4 in here. It's a pretty easy elimination if there's not, and it looks like there are 4 in there, so we're good there. Going into my rules, if M is on the team, O and P cannot be on the team. So I'm going to make sure that in my answer choices, M is not with O and P, which eliminates A, and that's it. That's the only one where M is in there. So we're going on to rule number 2. If S is on the team, both P and T must also be on the team. So every time I see S, I have to have P and T, which eliminates C because it's missing one of my variables, and D because it's missing one of my variables. And that's it. Going to rule number 2, if W is on the team, M and Y must also be on the team. So when I see W, I better see M and Y with it, which eliminates E. I'm missing one of them, which means B is my correct answer choice. All right, this is where we're going to start using our diagram. Number 9 says, which one of the following is a pair of employees who cannot be on the team together? So because I'm not restricted to if this is happening or whatever, I have to look at all of my worlds that are valid. So because it's looking for something that cannot be on the team together, my 4 wrong answer choices are going to be pairs that can be on the same team together. So for example, let's look at A, M, and T. Can that happen? That can happen, let me get my pen. That can happen right here. I could have T with M. So because it can be a pair that's on the same team together, I can eliminate A for this answer choice. O and Y, can I have that happen? I can actually have that happen down here. I could have O, Y, and then any one of my other variables. So because I can have it happen, and I'm looking for something that cannot happen, that one is a wrong answer choice. P and Z, that can actually happen here and also down here, but it's easiest to see up here. I can't have P and Z happening up here. So again, another wrong answer choice. S and W, I don't have that happening in any of my worlds, so I'm going to pick that one. E says W and Y. I can actually have that happen in this world. I can have W and Y together. So because it can happen, I can eliminate that. So my answer choice is D. Next question, if Y is not on the team, I'm going to pause there and I'm going to look at my worlds and see where Y is not on the team. That excludes this one. If Y is not on the team here, that means I'm only dealing with O and Z. O and Z could both be on the team, but O and Z, either O or Z has to at least be on it. I have Y there, so that's not one. And if I were to eliminate Y from my selection down here, it would have to be this order in order for it to be a valid world. Okay, so we're looking at this world, looking at this world. Okay, now what am I asked? That any of the following could be on the team except. So we're looking at an except question, which means that the 4 wrong answer choices could happen. My correct answer choice cannot happen. So could it be true that Z is on the team? Could be true in both of my worlds. I could have Z on the team. So because it can be true, it's wrong because we're looking for something that cannot be true. T, actually I have to have T on both my teams, so that one's a wrong answer choice. P, again, because I have to have it in both of my worlds, it's a wrong answer choice. O, I could have it in both of my worlds. And in fact, in one of them, I have to have O. So because it can happen, I'm looking for something that cannot happen. That is a wrong answer choice, which leaves me with M. And in both of my worlds, I do not have a possibility of having M. So that is my correct answer choice because I'm not having M happen in any of those worlds. Moving on to 11, if Payne is not on the team, I'm going to pause and look at where Payne is not on the team. That can happen here. That can happen here. And if Payne is not on the team, I have O, T, Y, and Z. So it can happen here. So I'm looking at 3 worlds. Okay, what am I being asked? Which one of the following could be true? Could it be true that neither M nor O is on the team? Nor O. M nor O. No, that's a wrong answer choice because I have to have either M or O. In this world, I have to have M. In this world, I have to have M. And in this world, I have to have O. So there can't be a world in which I don't have either of them. So wrong answer choice. Neither M nor T is on the team. Same thing happening. I have to have M here. I have to have M here. And yeah, T has to go here. So I can't have a world in which I do not have M and T on a team. M or T. Neither M nor Z on a team. Nope. So I have to have M in my first world. I have to have M and Z in my second world. And in my third world, I have to have Z. So I do not have a world in which I have neither M nor Z. Neither O nor T. I could have that happen here. I could pick Z and leave out my T, and that would leave out O and T. So I'm liking that one. And because it's a could be true, it only has to happen once. So I'm going to pick that and check out E. Neither O nor Y. In all 3 of my worlds, I have to have Y. So I can't have a world in which I don't have Y and O. Yeah. So my correct answer choice is D. Okay, last one. Which one of the following is a pair of employees, at least one of whom must be on the team? So this answer, or this question, is asking us to look at the pairs of answer choices, and we have to have at least one person within that pair on our team, on all of our teams, because it's a must be true. So for example, A says O and S. So when I go through my answer choice or my worlds, I'm looking for O and or S on my team in order for it to be a correct answer. So for example, in my first world, I could have it be where O and S are not included in this world. So that's actually a wrong answer because I'm looking for something that has to be true in all of my worlds. So we can eliminate A. O and W, could I have it be where I have neither of them? I could have it happen down here. I could exclude O and W in this world. And so because I'm looking for a must be true where at least one of them is on my team, this one is again a wrong answer choice. P and S, I could have it up here. I could put T here and I could have neither of them happening. So I can exclude P and S in this world, and I'm looking for an answer where I have at least one of my pairs in all of my worlds. T and Y, this is our answer. So in this world, I have Y. I could have T, but I'm going to have at least one of them regardless. This world, I have T. This world, I have T and Y. And in this world, I can't eliminate T and Y altogether because that means that I'm missing one of my variables. So I have to include at least one of them. So this is an answer choice where I have to have at least T or Y. I could have both, but at least one of them has to show up in my answer choice or in my world. So this is going to be our answer. But let's look at E, Y, and Z. I could exclude Y and Z in this world where I have neither of them. So this is another wrong answer choice because at least one of them has to be in all of my worlds. So why is this not working? Oh. So yeah, my answer choice is D. So that was the game. I think this is a pretty more advanced in and out game because we are looking at a minimum, maximum, amount of variables within our group, which makes it a little more advanced. We're not just kind of looking at, okay, what is the possibilities? We're looking at, okay, we have to have a minimum of 4. So we actually have to kind of do some counting in this game, but very doable game. If you have any questions about this game, please let me know. But other than that, that's the game.